All right, so we have one final example to finish off our lesson from section 5-4. The directions ask us to set up, but do not integrate for this problem. So the problem itself says that shampoo drips from a crack in the side of a plastic bottle at a rate modeled by the function y of t, which is equal to t divided by the square root of 1 plus t raised to the 3/2 power, where y of t is measured in ounces per minute. Then if there are 32 ounces in the bottle at time t is equal to 0, a question asks how many ounces are left in the bottle after 5 minutes. Okay, so I'm going to have you guys work on this one, so go ahead and pause the video, work through the setup of the integral on your own, and then you can turn it back on, and we'll take a look at how we set up the integral together. Okay, so let's go ahead and take a look at this one. So I'm going to zoom out a little bit so we can see the question and the write-up at the same time. Okay, so when we look at this problem, this statement right here, so if there are 32 ounces in the bottle at time t is equal to 0, that is our initial condition in this problem. Okay, so tells me that we're going to utilize the net change theorem. Now, we're not explicitly told here what the antiderivative of the function y of t is. But if y of t is measured in terms of ounces per minute, when we take the antiderivative of that, so if you picture like your Riemann sum, let's say you've got a graph that looks like this. When you do your Riemann sum, the heights are going to be written in terms of ounces per minute for the rectangles, and then your base length is going to be written in terms of time, which is in terms of minutes. So when you find the area underneath that curve, you're going to multiply these two units together. So you're going to multiply minutes times ounces per minute, which is going to leave us a measurement in terms of ounces. Okay, so that's going to be like a volume of some sort. So I'm going to go ahead and call the antiderivative of the function y, I'm going to call it the function v, indicating volume. Okay, and we know that there are 32 ounces in the bottle at time t is equal to 0, which means that v of 0 is going to be equal to 32. Okay. And then the question asks us how many ounces are left in the bottle after 5 minutes. So that is asking us then to calculate V of 5. So V of 5 is what we're trying to compute here. Okay, so if we want to use the net change theorem, our volume at time t is equal to 5 is going to be equal to V of 0 plus the integral from 0 to 5 of the function y of t, which we're integrating with respect to t. But actually, in this particular case, that's not going to be correct. Okay, so I want to take a look at like what's erroneous with that statement. Okay, now when we look at this function y of t, that function y of t, for t values that are going to be positive, which time has to be positive in this particular problem, the numerator, if t is positive, has to be positive, and the denominator, rad 1 plus t to the 3/2 power, that has to be positive as well, because an output for a square root function has to be 0 or positive. Okay, so when we have this integral set up, if y of t is positive, that means that the graph lies above the x-axis. When we take that integral, the integral from 0 to 5 of y of t, you're going to have a graph that lies above the x-axis. So when you compute the area underneath that curve, the area underneath that curve is going to be above the x-axis, thereby making that area a positive quantity. So when you compute this expression right here, you're going to have v of 0, which is 32 ounces, and then the integral from 0 to 5 is going to be some positive quantity. That means that there's going to be more than 32 ounces in the bottle at time t is equal to 0. I mean, at time t is equal to 5, and that doesn't make sense in the context of this problem. Now, we're told that shampoo is draining from a crack in the plastic bottle. So we want that rate to be negative. So there are two things or two ways that we can do that. We can either calculate v of 5 to be equal to v of 0. And then if I want that rate to be negative, I can take the opposite of y of t, which I'm integrating with respect to t. And that's one way to set this up. The other way to set this up is to take that negative and pull it out front of our integral, which would make v of 5 equal to v of 0 minus the integral from 0 to 5 of y of t, which we're integrating with respect to t. And if you think about like the computation that you're going to get for that, that's going to make sense, because this time when we take the integral from 0 to 5 of y of t, again, because that area lies above the t-axis, that area is going to be some positive quantity. We want that, that area is going to be some positive quantity. So when we subtract, we're going to wind up getting a volume at time t is equal to 5 that is less than the volume at time t is equal to 0. Okay, and that makes sense if the shampoo is draining from the plastic bottle. Okay, so again, these were a couple of examples that, like in the context of a word problem, utilize the net change theorem. All right, so that wraps up our lesson from section 5-4. We've got one more lesson in chapter 5 before we wrap up chapter 5, and that's going to deal with integration by u substitution. Okay, that's it for this lesson. We'll see you guys soon. Take care.